Hello guys, good morning, good afternoon, and good evening whenever and wherever you are watching this video from. Welcome to my YouTube channel. If this is your first time being on this channel, please consider subscribing. You can also like and share the video. Okay, now in this video we're going to answer this science paper 1, which is physics. Okay, so I'm going to explain, and as I'll be calculating, I'll be explaining. Okay, I'll be explaining as we prepare for your exams. Okay, now the first question. The diagram shows an extract from Vernier calipers being used to measure the diameter of a what? Of a pipe. Okay, so this is an extract given here to calculate the Vernier caliper, the reading of the instrument. To know, you need to know the reading of the what? Of the Vernier calipers. Okay, so this is the main scale, and this down is what? The Vernier scale. Okay, so what you do is that first come up with the reading on the the Vernier scale. Now, where do you start from? You start from the mark that is just before the 0 mark on the Vernier what? On the Vernier scale down here. So the mark on top on the main scale is this one. Now, what is the value of this? If this is 10, then this one is supposed to be what? 9.9. Why 9.9? Check, this is 10 and this is 11. And you have 10 what? 10 lines. Let's calculate together. This is, let's say, 10.1, 10.2, 10.3, 10.4, 10.5, 10.6, 0.7, 10.8, 10.9, 11. Okay, so this one here automatically is 9 point what? Main scale is 9.9 centimeters. Now, the Vernier scale, you should know that you need to multiply by the Vernier scale by 0.01 centimeters. Okay, that is a rule. Okay, the accuracy, arithmetic accuracy. So now look at this. What is the reading? What is the reading? Let me just do this. So the Vernier the main scale is 9.9 centimeters. So what is the reading of the what is Vernier scale? It is very simple. You start reading from this 0 up to the line, that the straight line that is starting from the main scale to the Vernier scale, and we find it here. Okay, so this is 0, 1, 2. If you continue, this will be 3, 4, 5. Okay, so this is 2. So we're going to multiply 2 times 0.01, and the answer will be 0.02 centimeters. Then we're going to now to add this and the main scale. Okay, so we have 9.9 plus 0.02. So you can just place the value there, 0, and then add. 2 plus 0 is 2. 9 plus 0 is 9. 9 plus 0 is still 9. So it's 9.92 centimeters. Okay, so the answer here is what? Is B. Okay, so it is very simple. All right, let's go. Don't forget to subscribe, by the way. Let's go to question 2. So question 2 is saying the swing of a simple pendulum whose angle of swing or amplitude is 10 degrees has a periodic time of 0.80 seconds. What would be the periodic time if the angle of the swing is reduced to 7? This is simple. Listen, as long as the angle of the swing is below 15 degrees, okay, is below 15 degrees, time is just the same. Okay, time is just the same. The difference is minimal. Okay, there's just a slight difference in decimals. So even here at 7 degrees, time will still be 0.8. Okay, 0.8 seconds. So A here is the answer. You don't need to struggle here. Okay, question 3. A digital balance reads 50 kg when a girl stands on it. What would be the mass and weight of the girl on the surface of the moon where the gravitational field strength is 1.7 Newton per kg? All right, this is simple. You should understand the principle of mass does not what? Mass does not change, okay, on Earth or on the moon. If someone is 50 kg on Earth, he will weigh 50 kg the moon, because mass does not what? Mass does not change. Okay. Now weight. Okay, weight changes. Weight will be is equals to mass times G. G is the gravitational what? Gravitational force or field. All right. So mass will be 50 kg, okay, times 1.7 Newton per kg. Okay. So kg and kg will cancel, which is telling us that by the way, since there is this this is division sign here, division meaning you're going to just cancelling kg and kg, just remaining with Newton, which tells you that weight should be what? Should be in newtons. Okay. All right. Now 50 times 1.7 is 85 newtons. So 85 newtons, that is weight. Then mass does not change. So mass 50, weight 85. So B is the answer here. Okay, B is the answer. It is as simple as that. Okay, let's go question 3. Projectile motion. The following diagram shows the motion of a ball that was dropped from a height of 2 meters and bounced back. Good. At which point A, B, C, and D is the ball having zero speed? Is the ball having what? Zero speed. Now this is what you should know. Let me explain projectile motion to you. Okay. Now listen. If you throw something at an angle, okay, it will move like this. Okay, it will move okay. Now at the starting point, so let me just divide this one into two parts so that you understand very well. So here at the starting point here, the speed is at its maximum. Okay, is at its what? Maximum, and the speed is reducing as it's projecting what? Towards this point. Okay, the maximum height. Okay, now when it reaches here, this is where now the speed is what? Is zero. The speed is zero. Then at C, the speed starts increasing. At D, the speed is what? Is maximum. So this is maximum and this is also maximum. I understand that maybe in your exam this question may not come as like this. They may ask you where it is the what? Maximum. Just know that at A and at D, that's the maximum. But where there is zero speed is at what? At B. So B is the answer to question what? Question 4. Okay. Let's go to question 5. Okay. Question 5 is saying a ball was kicked vertically upwards with a velocity of 8 meters per second. How high did it what? How high did it rise? Okay. How high did it rise? Okay. Now this is distance. Now how do you calculate distance? This is now you need to think now about among the equation of what motions, which one do we use here? Okay, and the formula is very simple. The formula which we're going to use where there is no time, we don't have time here. We also don't have mass. So what you do is velocity squared is equals to, which is the initial final velocity, is equals to initial velocity plus, okay, plus 2as, okay, as or ax, just the same. Let me just use x here, ax, okay, where x is the distance we want to calculate now. Okay, so what you can do here, we can just solve for x, make x the same formula, or we just substitute in the equation and we'll find the answer. Let's just substitute v squared, which is the final velocity. When you kick a ball vertically, is supposed to be what? Is 0. Okay, it's supposed to be 0. That is what we call zero speed. Okay, 0. All right, so it will be 0 squared is equals to, what is the initial velocity? Initial velocity here is 8, so it will be 80 squared plus 2 open bracket. Now what is a is acceleration due to what? Acceleration due to gravity. Okay, throwing upward. Okay, when you're throwing upward something, the acceleration due to gravity, this will be what? This is negative, so we're going to write negative what? Negative 10 meters per second squared, which is just, let's just write negative 10, then x. All right, okay, 0 squared is going to give us 0. 8 squared is 64. 2 times negative 10 is negative 20x. Okay, then the 64 crosses the cosine, it becomes negative 64. Okay, is equals to negative 20x. We want to find it for x, so I'm going to divide both sides by negative 20, even here negative 20. This and this cancel. X is equals to negative and negative positive will cancel. Then, so you just use a calculator here so that you don't waste what? You don't waste the time. 64 divided by what? 20. My calculator is giving me 3.2 meters. Okay, is the answer. So when you look at our question here, which one is the answer? C. Okay, C is the answer. So it is this simple. All right, question 6. This is under simple machines. The following diagram shows wheels used to drive a grinding mill. Good. Driving wheel and then driven wheel. What is the mechanical advantage? All right, so mechanical advantage is equals to driven, okay, for this one, driven over driving. It is a ratio. So driven is 50 centimeters, then driving is 10 centimeters. Centimeters and 10 centimeters we cancel. 0 cancel. 1 into 5 is just 5.0. It's a ratio, so no units. 5.0. So C here is the what? Is the answer. Don't waste time here. Let's proceed. Okay. A boy of mass 50 kg runs up a flight of stairs in 10 seconds. Good. The vertical height of the stairs is 5 meters. Okay. What is the average power developed by the boy? What is the average power developed by the boy. Okay, this is simple, but you need to first calculate something. So first, let's analyze, right, the what? The formula for what? Power. All right. Okay, so the formula for power here is work done over time what? Work done over time taken. Now, what is work? All right, so how can you calculate work here? This is very simple. So what we're going to do, work, we're going to use here, work done is the increase what in the potential gravitational potential energy. All right, gravitational potential energy. So we're going to say is equals to mgh. Okay, mgh. Now what is m? M is mass, which is 50 kg. What is g? Gravitational energy, which is just 10. Okay, acceleration due to gravity, 10. Then what is h? H is height, so in meters, which is just 5. Okay, so 50 times 10 is 500. So 2,500 kilo. Is it 2,500? Let me just calculate here nicely, so I don't make a mistake. Okay, times 50 times 5, 2,500. 2,500. The units, joules. Okay, joules. Then, having calculated that, what is time? Time is 10 seconds. 10 seconds. So let's substitute here. What is, so work we've calculated here is what? 2,500 joules over time 10 seconds. So this 0 and this 0 cancel. This is giving us 1 into 250, just 250 joules per second, which is just watts. Okay, the same as 250 watts. All right, so the answer, do you have 250? Okay, good, we have number C. Okay, let's go to 8. A copper rod is heated at one end. Which statement describes how heat transfer occurs in the copper rod? Okay, the energetic copper molecules move from the cooler end to the hotter end. No. B, the energetic copper molecules, are these even molecules? They're not molecules, these are free electrons. So A and B automatically, these are not what? Correct options. Let's go to C. Energetic free molecules move from the cooler end to the, no, they don't move from the cooler end, they move from the hotter end to the cooler end. Okay, hotter end to the cooler end, that is by what? Conduction. So let's go to D. Energetic free molecules move from the hotter end to the cooler end. D is the best option here. Question 9. The following diagram shows a fire alarm. Okay, the bimetallic strip is used to complete the circuit when there is a fire. Okay. So what's the question saying? Which of the following statement is true when the alarm rings? A, metal A contracts more than metal B. Metal A contracts more than metal B. And no. Listen. So you have the issue of point of contacts here. When they come into contact, that's when what? That's when the alarm goes off. Okay, it rings. Now, this is like this. When something burns like this, okay, you have metal A here. Let's say metal A, or this one metal A, then this one metal B. For it to cause the bending here, what causes the bending? Is it metal A or metal what? Is it metal A or metal B? Okay, to cause the bending, it means metal B expands more than metal what? Metal A. Okay, so for this to reach to touch here, for metal B, for this bimetallic strip to touch here, it means that metal B expands more than what? More than metal A. So let's check for that solution. Metal B expands more than metal A. Metal B expands more than metal A. Metal A expands more than, no, metal B expands more than metal A. D is the best option here. Let's go to 10. Which statement is true when a water wave moves from deeper waters to shallow waters? A, frequency decreases. B, frequency increases. C, wavelength increases. D, wavelength. C, wavelength decreases. D, wavelength increases. Wavelength decreases is the best answer here. Okay, as you move from deeper waters to shallow water, waters, wavelength decreases. This is simple. Question 11. The diagram shows a metal rule clamped at one end and set into vibration. It produces 300 vibration in 2 seconds. Okay, 300 vibration in what? In 2 seconds. Calculate the frequency of vibration. Oh, okay. So frequency is equals to number of vibration over time. So it will be 300 over time taken 2. So this is 150 hertz. 150 hertz B. Okay, here. All right, let's go to question 12. If 5 seconds elapsed between a lightning flash and the clap of thunder, how far away is the storm if the speed of sound in air is 340 meters per second? Okay, so distance is equals to what? Speed multiplied by what? Time taken. All right, so here distance is equal to, what is speed? 340 meters per second multiplied by, what is time? 5 seconds. 5 seconds. So 5 times 34, 340. Don't waste time, use calculator. 340 multiplied by 5, 1700. So the second and second cancel, just remain with what? Meters. So 1700 meters. So D is the best answer here. Okay, let's go to question 13. Question 13. The following diagram shows reflected ray from a plane mirror to an observer. Okay, so you have the plane mirror here. Okay, which letter A, B, C, or D shows the position of the object? This is an observer, you see, so it's supposed to reflect like that. Okay, at an angle, reflecting like this. So this is where the object is, this side. So C is the what? C is the best answer here. Let's go to 14. Okay, 14. The following diagram shows a ray of light from air into glass of refractive index 1.6. Refractive index 1.6. Okay, so we have here the angle of incidence, the angle of refraction here we don't have, is x. Calculate the angle x. So it's the one we are asked to what? We are asked to calculate. Now, how do you calculate that? It is very simple. So we have the formula is the constant number, which is the refractive index, is equals to sine of angle, the angle of incidence over sine of the angle of what? Refraction. Okay, refraction. So now, if you substitute here what you are given, n is the refractive index, which is 1.6. So go to say 1.6 is equals to sine I is 60. So sine 60 over sine r. Then you cross multiply. So over 1. When you cross multiply, you're going to have 1.6 sine r is equals to sine r, yes, is equals to sine 60. Sine 60 degrees. You divide both sides by 1.6, even the side 1. What? Both sides by 1.6. So sine r is equals to sine 60 over 1.6. Okay? Sine 60 over 1.6, or you can just do this. So on both sides, you're going to find the sine inverse of r. So we're going to say r, sine inverse like this in brackets. What you're going to find here, or just substitute the way it is, you're going to find the same answer. Okay, so shift on your calculator, sine inverse open bracket sine 60 divided by 1.6. okay, close. You're going to have sine inverse of 0.54. when you do your calculations here, 54. Okay, so when you go on your calculator and punch sine inverse of what? 0.54, you're going to have it's giving me 32. It's giving me 32 is giving you 32.8. okay, to one decimal place, 32.8. okay, so this is the answer. So the answer is 32.8, B. That's the answer. Okay, if you are still together up to this point, guys, consider subscribing. You can also like and also give us a comment so that this video is also recommended to others as well. Okay, let's go to question 50. One of my favorite topics in physics. The diagram shows a permanent magnet placed inside a coil from the direction of the arrow. Okay, this side, so it was placed this side. Now, there are some things that you need to know here. But first, let's read the question. What would have been the response of the needle on G as the magnet was being pushed inside the coil this direction? So the direction will move, the needle will move this side towards the right, will deflect to the right. Okay, to the right. Now, so what's happening here? This is according to the what? To Lenz's law. Now, as you are pushing your magnet towards this this side, okay, inside here, what will be happening is that the needle here will deflect, okay, towards the right. If you are removing it, it will deflect towards the what? Towards the left. Okay, towards the left. Okay, so I think that's the simplest explanation we can give here. All right, for more explanation, you have a lot of lessons, physics lessons, on our WhatsApp, in our WhatsApp group, so you can join us if you want. All right, let's go to question 16. No, what's the answer? Deflected to the left, deflected to the right. C is the answer. Okay, question 16. A negatively charged rod is brought closer to an isolated what? T-shaped piece of what? Piece of metal. Okay. T-shaped piece of metal. Initially, the metal is uncharged. Good. Which diagram shows the induced charge on the metal? Okay, induced charge on the metal. It is very simple. Here it is very simple. Now let me explain this. If you have a rod here and it's negatively charged, let me just start first charging by charging by conduction. Conduction, it means that the two metals have to be what? Have to be in what? In contact. In contact. All right, it has to be in contact for you to charge. And if it's in contact, then there will be repulsion. The negative electrons here, or the electrons will move towards the right, okay, and the positively charged electrons will be what? On the left. Okay, will be on the left. Now this is by what? Conduction. Conduction means there is a point of contact. Now when you look at this, there is no contact here, so this is by induction. So that, I mean, so is you induce, okay, induction, not conduction. So just need a rod here and it says negative. You have a metal this side, so there will still be repulsion. The negative electrons will move towards the right here, and you just remain with what? Positive here, so that this one is also what? Is charged. Okay. Now when you look at the options here, A, you have negative here and the positive, and the negative electrons are pushed there. I think this one is best. Okay. Now let's go to B. B, negative, positive. No. Negative, there'll be repulsion. No. Negative, no. The answer is what? A. Okay. 16, question 16. Let's go to question 17. 17. Question 17. An immersion water heater is marked 240 volts, then 2 kilowatts, and it runs for 120 minutes. If the cost of 1 unit, which is kilowatt hour, of electricity is 0.8 kwacha, 80 kwacha, just 0.8 kwacha, which is just 8 ngwe. What is the cost of running this water heater? Now, first thing, you need to calculate what? Electrical what? Energy. Okay? And electrical energy is very simple. It is power multiplied by what? Multiplied by time. Now you need to know that this time here has to be in what? Hours. And this power has to be in kilowatts, of which this one is in what? Already in kilowatts, so it's fine. Okay? It's fine. But time is not in hours. Okay, so you need to convert 120 minutes, just divide by 60 minutes. This is just 2 hours. Okay, so energy, electrical energy will be or units will be power 2 kilowatts multiplied by 2 kilowatts multiplied by 2 hours. 2 times 2, 4. So 4 kilowatts hour. So these are the units. Then let's use proportions to calculate the cost here. So what we're going to do, we're going to say 1 unit is 80 what? 0.80 kwacha here. Then 4 units, this is 4 units kilowatt hour. 4 units will cost how much? Cross multiply x times this, x times 1, just x, then 4 times 0. So 4 times 0.8 is giving me 3.2. So 3.2 kwacha, which is just 0.20 here. A is the answer. Great. This is very simple. Okay, let's go to question 18. Question 18, the diagram shows a 12 volts 3 amp lamp being operated by a transformer using a 240 volt supply. Okay, 240 volt supply. Then here the question is saying, if the transformer is 100% efficient, what current will flow from the supply? So we are being asked to calculate what? Current. And the current, you know that here current will be, current is equals to power over what? Over voltage. Okay, now how do we calculate? Do we know power? Power we don't know. So power is very simple. Power is equals to what? V times what? I. That's very simple. Okay, so power is equals to, what is voltage? Is 12 volts. What is the current? The current of the lamp is what? 3 amp. So 12 times 3 is what? 36 watts. So volt amps. So it's just 36 watts. Now we want to calculate the what? The current which will flow from the what? Supply. Okay, so current is equals to the way power, so 36 over voltage 240. So let's calculate 336, by the way, 360. 36 divided by 240 is giving me 0.15 amps. Yes, A here is the answer. Okay, A is the answer. Let's go to question 19. So section A, we're just remaining with 2 questions. All right, question 19. This is under Introduction to Electronics. The diagram shows an alternative voltage applied to the input of an oscilloscope. The sensitivity is set to 3 volts per centimeter. Good. 3 volts per what? Per centimeter. Then you have a key here. A single small box represents 1 centimeter. Great. Okay. What is the maximum voltage? This is simple. Maximum voltage here. Let's look at this wave. So we're going to say the maximum point of every wave here from the resting position here. How many boxes are there? We have 1, 2, 3, 4. 4. So we're going to say 4 centimeters multiplied by what? 3 volts per what? Centimeter. Centimeter will cancel. 4 times 3 is 12. So 12 volts. That means 12 volts, which is just A. Number 19 is A. Okay. So you can use this. You can also use here just to get the maximum point here of this wave. Okay. Then you are good to go. Let's answer the last question in section A. This is under radioactivity. A radioactive nucleus of an atom of an element emits an alpha particle. What change occurs to the parent nuclide? What change will occur? What change occurs to the parent nuclide? after the decay. Alpha particle. What is an alpha particle? An alpha particle is just a helium. Simple. Helium is 2 here. Now, what will happen to the parent nuclide? Number one is that the mass number decreases by what? By 4. Mass number is also known as the nuclear number. So let's look at A and B. Nuclear number decreases by 2. No, it decreases by 4. B, nuclear number increases by 4. No, it decreases by 4. All right. Then, so about nuclear number, that's all. Then what happened to the proton number or atomic number? Atomic number decreases by 2. Okay, atomic number decreases by 2 in the parent what? Nuclide. Okay. So what will happen here? Let's look at C. Proton number decreases by 2. Yes, C is the best answer here. Okay. Then D, proton number increases by 4. No. So that's it. Physics is very simple. As long as you do a lot of practice, okay, you practice a lot. If you have been together up to the last point, you are great. You are great. Just comment in the comment section that you've finished this this video to the question 20. All right. Okay. Then in the second video, we're going to look at section B. Okay, section B. Thank you so much for watching. God bless you and all the best in your studies.